Bill Nye, the man of science, has been thrilling us with the latest discoveries and all their mysteries for decades. Bill Nye has piqued our interest in the final frontier and its enigmas as he introduces us to the vastness of space that surrounds us and stretches infinitely above us. Now, Bill Nye breaks his silence on the most recent images from the James Webb Telescope, which offer us a glimpse into the universe more than 13 billion years ago, fundamentally altering our knowledge of the cosmos and our perspective on life itself. This telescope is making discoveries about planets, distant galaxies, and much more. It is a revolutionary scientific breakthrough and a worthy successor to the Hubble Space Telescope. So what is so special about the Webb's images that defied our expectations and theories, and what does Bill Nye have to say about them? The creation of this telescope was the result of years of work by NASA scientists and engineers. Launched on Christmas Day 2021, the various steps of the telescope's deployment proceeded smoothly over the next few months, and by the end of June 2022, scientists began to discover thousands of new galaxies older and more distant than previously known. Some of these galaxies might have been formed 150 million years before Hubble's oldest discovery. In addition, the telescope is able to capture enough light from celestial objects such as exoplanets and stars to reveal their composition and trajectories through space. Bill Nye says that these data are already beginning to reveal in great detail the atmospheric composition of planets light years away from Earth, allowing scientists to suggest their potential to harbor life as we know it. One of the Hubble Space Telescope's most recognizable sights has long been the Pillars of Creation in the Eagle Nebula. This structure was visible to the telescope that primarily detects visible light, but the processes of creation within it were not. However, they were captured by the Webb telescope's infrared image in the form of many protostars. These appear as clusters of dust and gas, each several times larger than our solar system, appearing as tiny red dots against the background of the pillars. These protostars are still in the process of formation and are not yet consuming hydrogen. According to Bill Nye, as more material is attracted to the center of the star, it becomes denser and denser until it suddenly reaches such a density that hydrogen burning begins, causing a dramatic rise in temperature to about 2 million degrees Celsius. Two different colors in the image represent infrared wavelengths, which are mostly invisible to us. The only visible part of the image appears blue. The hues also increase the red radiation in the image since the protostars generate radiation at a wavelength 6 times longer than that of the human eye. According to Bill Nye, this image not only demonstrates the infrared capabilities of the Webb telescope but also the formation of stars like our Sun. The first exoplanets were found in the 1990s, and today there are more than 3,000 confirmed planets orbiting distant stars. However, only a few of them have been directly imaged. Most exoplanets are so far away that they can only be detected when the light from their host star is dimmed. The first direct image of an exoplanet was taken in September last year. This planet was identified in 2017 and given the name HIP 65426b. Scientists used monographs on telescopes to exclude light from the central star, along with 2 of the Webb telescope's cameras, a series of filters, and other equipment to observe it. The planet has several features that make it easier to see. In addition to having outstanding infrared sensitivity, this planet is extremely far from its host star, at a distance 100 times greater than the distance between Earth and the Sun. It is a massive gas giant nearly 12 times the size of Jupiter. The Ghost Galaxy, also known as Messier 74, M74, is a spectacular celestial object that remains elusive to the naked eye due to its faint brightness. However, with the help of advanced astronomical instruments, particularly infrared cameras, its brilliance can be captured and studied in great detail. Positioned in the constellation Pisces, this galaxy is a magnificent example of a face-on spiral galaxy, showcasing its symmetrical structure and intricate star formations. While its optical view highlights an impressive array of stars spiraling outward from a radiant core, recent observations have revealed even more intricate details about its composition and activity. Traditionally, M74 has been appreciated for its nearly perfect spiral structure, which is formed by a combination of gravity and the movement of stars, gas, and dust within the galaxy. The optical view of the Ghost Galaxy allows astronomers to observe its radiating arms populated with countless stars of various sizes and stages of life. These stars light up the spiral arms, giving the galaxy its iconic appearance. Despite this visual grandeur, much of the galaxy's secrets lie hidden in wavelengths of light beyond the visible spectrum, requiring advanced tools like the James Webb Space Telescope to uncover. Recent images captured by the Webb telescope have offered unprecedented insights into the ghost galaxy, uncovering structures that were previously unseen. Unlike the optical images, which primarily highlight stars, the infrared observations reveal intricate filaments of heat-emitting dust and gas. These structures, which resemble glowing fibers, emanate from the galaxy's central region, depicted in striking electric blue tones in the Webb images. The ability to detect infrared wavelengths has allowed astronomers to peer through the layers of dust that often obscure optical views, unveiling dynamic processes taking place within the galaxy. One of the most exciting revelations from these observations is the illumination of star-forming regions scattered along the galaxy's spiral arms. Star formation is a fundamental process that shapes the evolution of galaxies, and identifying these regions is crucial for understanding how galaxies like M74 develop over time. In the ghost galaxy, these star-forming regions appear as bright spots embedded within the dust and gas filaments. The dust, composed of tiny particles that absorb and re-emit light, plays a vital role in the birth of stars, as it helps to cool the surrounding gas, allowing it to collapse under gravity and form new stellar bodies. The Webb telescope's sharp infrared sensitivity not only highlights these star-forming regions but also allows astronomers to measure their sizes, ages, and masses with remarkable precision. This detailed information provides clues about the galaxy's overall history and the environmental factors driving its evolution. Furthermore, the infrared images enhance our understanding of the interstellar medium, the diffuse material that fills the space between stars in galaxies. By studying the dust particles scattered throughout M74, researchers can gain insights into the chemical composition and physical properties of this material. The ghost galaxy's elusive beauty has been brought to light through the advanced imaging capabilities of the Webb telescope. By capturing intricate details invisible to the naked eye, the telescope has not only deepened our appreciation of M74's structure, but also expanded our understanding of the processes that shape galaxies. These discoveries demonstrate the power of modern astronomy in revealing the hidden wonders of the universe. In the infinite landscape of photos, images from the Hubble and Webb space telescopes have been combined to create a stunning composite image that highlights portions of the optical and infrared views of the galaxy. The composite image was produced by researchers at the European Space Agency (ESA) as part of the PHANGS project, an international initiative using Hubble, Webb, and various ground-based telescopes to observe 19 nearby galaxies in the infrared. With Webb's sharp observations at longer wavelengths, astronomers can identify star formation regions in galaxies, accurately measure the masses and ages of star clusters, and study the characteristics of tiny dust particles wandering through interstellar space. In an image of a distant star known as Wolf-Rayet 140, taken in July last year, a recognizable diffraction pattern, a visible imaging artifact, was observed. However, this star is also surrounded by an equally unrealistic pattern of wavy, concentrated rings with a slightly square shape. These rings, in contrast to the diffraction pattern, are characteristics of massive stars known as Wolf-Rayet stars, which are in the late stages of their lives and have already emitted a significant amount of hydrogen. The interaction between WR-140 and a small companion star gives rise to the peculiar shapes of the rings. The Webb telescope is designed to see the farthest galaxies in the universe, and in mid-December of last year, researchers announced that they had detected 4 of the oldest known galaxies seen for the first time by Webb. These galaxies date back 13.4 billion years, when the universe was only 350 million years old, or about 2% of its present-day age. These 4 galaxies, similar to hundreds of others discovered by Webb, are thought to be extremely old. Researchers determined the age of the galaxies as part of the JADE strategic survey using information from the near-infrared spectrograph to rapidly measure the galaxy's remoteness. This elongation of light waves, caused by the expansion of the universe, is measured by the redshift of galaxies. The largest redshift ever measured was 13.2. These galaxies are more than what we could have predicted to discover before James Webb. For the first time, We can locate protogalaxies with this telescope and spectrographically verify their extreme distances. Meanwhile, the Webb telescope has studied a planet orbiting a star in the constellation Virgo, conducting one of the most extensive investigations of extrasolar planets. The planet's name is WASP-39b, and it is located 700 light-years from Earth, about 8 times closer to its star than Mercury is to the Sun. This Saturn-sized gas giant boils as it orbits its star. Its atmosphere is dominated by thick clouds containing sulfur and silicates, including sulfur dioxide. Scientists were able to identify carbon dioxide in its atmosphere using 2 of Webb's spectrographs.